Ever wondered how machines understand text, images, or recommendations? The secret weapon is embeddings, and they power almost every modern AI system. So in this video, we will learn what embeddings are, why they are so important, how they work at a high level, and where you see them in real life, search, RAG, recommendations, and more. So what is an embedding? An embedding is a numerical representation of data, words, images, products, users as a list of numbers usually called a vector. For example, the word cat might be converted into something like 0.8 minus 0.3, 1.2, and a lot of other numbers in multi-dimensionality vector, a dense vector of numbers. What makes embeddings powerful is that similar things with similar vectors. The vectors for cat and kitten end up close in the space. Cat and car end up farther apart. Embeddings turn meaning and relationship into distance in a numerical space. Why do we need embeddings? Raw data like text or images is messy and hard for math to handle directly. Images are grids of pixels. Text is sequence of words. Machines prefer numbers they can compute with. Embeddings solve this by transforming complex data into compact vectors, preserving semantic meaning. Similar items stay close in the embedding space, reducing dimensionality while keeping the most important patterns. This is why embeddings are the backbone of NLP, recommendation systems, semantic search, and RAG pipelines. They let models feel similarity instead of just matching exact keywords. So how are embeddings created? So embeddings are usually learned by neural networks during training. For text, models like word2vec, Clove, or BERT read huge amounts of sentences and slowly adjust word vectors so that words appearing in similar contexts get similar embeddings. In a standard architecture, an embedding layer maps each word ID like an index to a vector. At first, these vectors are random, but as the model trains on a task such as predicting the next word, the vectors get tuned so that the overall loss is minimized. Over time, the model discovers that certain directions in the vector space corresponds to meaningful concepts like male versus female, location versus object, or positive versus negative, all encoded inside the numbers. Now, where you see embeddings in action? Once you have embeddings, you can do powerful things mechanically. Search and RAG. Turn your query and documents into embeddings. Then find the closest vectors. That's how semantic search and RAG retrieve relevant context. Recommendations. Map users and items into the same space so the system can suggest things close to what you love. Clustering and anomaly detection. Group similar customers, posts, or transactions, or flag outliers that lie far from clusters. In short, embeddings turn meaning into geometry. Distance between two vectors tells the model how similar or different two things are without any hard-coded rules. Embeddings are the quiet heroes of machine learning. They convert messy real-world data into structured, meaningful vectors that capture relationships and similarities. Whether you're using chatbot, RAG pipeline, or streaming service recommendations, you're directly using embeddings. If you want, comment embeddings deep dive and I'll break down word2vec, BERT, and vector database in the next video. Thank you so much for watching. This is the class 4 of AI engineer course. Thank you so much for watching till the end. I'll meet you in another video. Till then, keep learning.